All right, chain rule. Chain rule's a big dog. Absolutely huge. We are talking about when you have one function inside another. Here's a couple of really, really good examples. The square root of x cubed plus 2 is the combination of the square root and x cubed plus 2. So x cubed plus 2 has been substituted into the square root. And here's another one where x squared has been substituted into sine x. These are a composition of functions, and you can take the derivative of these, but you will not take the derivative of each of those functions at the same time. It happens in a sequence, okay? And so there's the notation for it. F composite g of x is the same as f of g of x. And then, so here is the derivative. So I'll be saying this a million times. If you have f of g of x, which you're taking the derivative of, you'll take the derivative of the outside function. On the first one, the outside function was a square root. On the second one, the outside function was a sine. Then you will copy the inside function just as it is inside, copy. And then the derivative of the inside. And here's a really good explanation of this using a u substitution. That dy dx could equal this, the du's canceling out. So this would be read as the derivative of y, the outside function, with respect to the inside function. That means you copy the inside function inside after you've taken the derivative. We'll see this in a bunch of examples. Then times, you take the derivative of the inside function with respect to x. Okay, so with respect to means what variable are you using? So if I say with respect to u, it would be with respect to x cubed plus 2, or with respect to x squared, meaning that's what you would write down rather than x. Okay, all right. So this is a wonderful example of why you need it. So if I was going to take the derivative of 5x plus 2, 3 squared, then with the chain rule, you would say f prime of x is equal to 2 copy. So this means that this is the with respect to 5x plus 3, right, to the first power. Chain rule is the derivative of the inside. So this is going to be the du dx part, and that is times 5. Okay, which could simplify as 50x plus 30. Now, I love this because without the chain rule, this is one where we could do it without the chain rule just by expanding this. So f of x, which actually might be I don't know, they're about the same. All right, so this would be 25x squared. So this is one that you could have done the derivative of without knowing the chain rule. But I kind of love it because it's showing you kind of why you need to have an additional thing. You couldn't just drop that exponent down. There was something else going on. In other words, over here, you couldn't just drop that exponent and be done with it, because if so, it would not equal what this one is going to equal to right now. Okay, so this is doing the power rule, 50 x to the first power plus 30. They're the same. As well they should be.